Hello guys, welcome to this video. In today's video, we're talking about homogeneous functions and Euler's theorem. Now for a function, let's say f of x, y. For this function to be homogeneous, it means that when we input lambda x in place of x and input lambda y in place of y into the function, we should have lambda raised to the power n f of x, y. So this is the criteria for a homogeneous function. So for that function to be homogeneous, it means that we should have lambda raised to the power n of the original function when we replace x to be lambda x and y to be lambda y. So here we have this question. It says determine if the function f of xy is equal to 3x squared plus 5xy plus 2y squared is a homogeneous function and hence find its degree. Now remember, the criteria for a homogeneous function is that when we input lambda x and lambda y in place of x and y, we should be having lambda raised to the power n f of x, y as lambda raised to the power n of the original function. Now let's replace x to be lambda x and y to be lambda y in the function. So we'll be having f of lambda x, lambda y will be equal to 3 into lambda x whole squared. Here we see x, we put lambda x, and 5 into, this is the function, so 5 into lambda x, lambda y plus 2 into lambda y squared. Now this is going to be giving us 3 lambda square x square plus 5 lambda x lambda y plus 2 lambda square y square. So this will give us 3 lambda square x square plus lambda times lambda will give us lambda square. So we have 5 lambda square xy plus 2 lambda square y square. So now we are going to factor out lambda square since lambda square is common. So factoring out lambda square, we'll be having lambda square into 3x square plus 5xy plus 2y square. So now let's go back to the criteria of a homogeneous function and check. So for us to have a homogeneous function, we should, when we input lambda x and lambda y, we should have lambda raised to the power n of the original function. So now let's go back to here. We have lambda raised to the power 2, and if you look at the original function, it's the same thing, which is 3x squared plus 5xy plus 2y squared. So this function is a homogeneous function because it has satisfied the criteria for a homogeneous function. Now, for us to find the degree of a homogeneous function, the degree of a homogeneous function is the power of lambda. So the power of lambda here, which is 2, is the degree of the homogeneous function. So the degree is 2. So that is just what they're asking us to find. So here we have another question. It says determine if the function f of x comma y is equal to x cubed plus y cubed all over x minus y is a homogeneous function and hence find its degree. Now it's almost the same question, it's just the change of function. So now remember the criteria for a homogeneous function. For us to have a homogeneous function, when we input lambda x and lambda y into the function, we'll be having lambda raised to the power n of the original function. So the function we have here is x cubed plus y cubed all over x minus y. Now, we are looking for the homogeneous function. We are checking if it's a homogeneous function. We are going to impute lambda x and lambda y in place of x and y. So we have lambda x, lambda y is equal to lambda x cubed plus lambda, lambda y cubed all over lambda x minus lambda y. Now what we just did is that we replace we replace x as lambda x and y as lambda y. So now this is going to be giving us lambda cube x cube plus lambda cube y cube all over lambda x minus lambda y. Now let's try factoring out lambda from the numerator and the denominator. Be having lambda cube into x cube plus y cube all over lambda into x minus y. We having lambda cube minus 1. This lambda now is cancelling this one. So into x cube plus y cube all over x minus y. Now we'll be left with lambda square into x cube plus y cube all over x minus y. Now we have gone back to this. We have our lambda square and we have the original function, which is x cube plus y cube over x minus y. So we have been able to prove that this function is a homogeneous function. And what is the degree of the function? The degree of the function is 2. So now for Euler's theorem, we have that x partial f of partial x plus y partial f partial y is equal to n of the original function. So this is Euler's theorem, and n is the degree of the function. So what this means is that Euler's theorem applies only for homogeneous functions. It works only for homogeneous functions because we can only get the degree of a function if the function is homogeneous. So here we have this question. It says verify Euler's theorem for the function f of x comma y equal to 3x squared plus 5xy plus 2y squared. Now what is Euler's theorem? Euler's theorem is x partial f partial x plus y partial f partial y is equal to n of the original function, where n is the degree of the function. So what we have to do now is to find the degree of the function. Now if you look at this function, you observe that this is the function that we solved first for homogeneous functions. So we found the degree of the function to be 2. But if we didn't solve for this function, there's another way we can be able to find the degree of the function without going through all the process of solving homogeneous functions. So what we can just do is that for each term of the function, we add the powers of the variable. So here the power of this term 3x squared is 2. The power of the variable is 2. Now let's check the second term 5xy. The power is 2 also because x is raised to the power 1 and y is raised to the power 1. So if we add them, we'll have 2. And why the last one, 2y squared? The power of the variable is 2 because we have y to the power 2. So if you watch, the powers are the same. That means the function is homogeneous and the degree of the function is 2. So that is another way of finding the degree of the function without going through all the processes of, solving homogeneous functions. So now, since we have found the degree to be 2, we have to find partial f over partial x. So for partial f over partial x, we are differentiating with respect to only x. We'll be having 6x, differentiating the first term, we're having 6x plus 5y. Differentiating 2y squared, we'll be having 0. So then for partial f over partial y, differentiating 3x squared with respect to y, we'll be having 0. Differentiating 5xy with respect to y, we'll be having 5, be having 5x, and differentiating 2y squared with respect to y, be having 4y. So now we have gotten our partial f over partial x and partial f over partial y. The next thing now is that we are going to input it into the Euler's theorem and verify if it satisfies Euler's theorem. So for Euler's theorem, we have x partial f over partial x plus y partial f over partial y is equal to 2. Now, the degree is 2 for the function f of x, y. Now, we have x. What is our partial f over partial x? We have 6x plus 5y. So 6x plus 5y plus y into our partial f over partial y is 5x plus 4y. So x times 6x will have 6x squared plus 5y times x will have 5xy plus y times 5x will have 5xy plus y times 4y will have 4y squared. So we are now going to be having 6x squared plus 10xy plus 4y squared. Now, if you look at this, we can factor out 2 from it. So we're having 2 into 3x squared plus 5xy plus 2y squared. Now let's go back to the function. If you observe, you see that this value is the same as the original function, and that means we have been able to satisfy Euler's theorem because we are trying to prove that this is equal to 2 of the original function. So this is 2 of the original function. So that means that Euler's theorem has been verified. So that's it for this video. Please don't forget to like, share and subscribe. I'll see you in my next one.